Given that the following equation that x is equals to sine cube theta and y is equals to 3 sine square cosine square theta, where theta is between 0 and pi over 2, our first job is to show that dy dx equals to 2 coordinate theta minus tan theta. Alright, so this one is just basically parametric differentiation. You by experience by now you should know that if you do dy dx and in terms of theta, you know that dy dx you have to first find dy d theta, and after that you also need to find dx d theta. Okay, so with this in mind, our main role is to first find what is dx d theta. Now dx d theta, just differentiate this, power goes in front, right? Power drops by 1, differentiate inside, you have a cosine theta, and your y dy d theta you may need to apply product rule, right? So differentiate the left side, differentiate sine square, this gives us 2 sine theta cosine theta, multiply by the right side, plus differentiate the right side, that gives us a negative sine, keeping 3 sine square theta, right? And simplify this, what you're going to get is basically 3 sine theta, 2 cosine square theta minus sine square theta. Okay, can. And dy dx over here, because it's equals to dy d theta divided by dx theta, this is dy d theta divided by dx d theta. Okay, simplify this, cancel, what you're going to get is something like 2 cos square theta minus sine square theta over sine theta cos theta, which is the same as 2 cos theta over sine theta, alright, minus sine theta over cosine theta, because I basically split into two fractions now. So I'm going to write this over this, then cosine cancel off to give me cosine over sine, this over this, and sine cancel off to give me sine over cosine. And cosine over sine just is 2 cotangent theta, sine over cosine just tangent theta. Therefore, shown.